The next generation of servers is going to require more power as workloads push the latest chipsets and accelerators to their limits. As the thermal design power or TDP of chips goes up, the heat output of servers could be well above 1.5 to 2 kilowatts for a single node. For that reason, QCT offers a liquid-to-air cooling solution called QCT QoolRack. QCT QoolRack is compliant with 19-inch EIA and 21 OCP open standards with L11 flexibility that no additional data center infrastructure needed and can be placed alongside any brand of traditionally air-cooled server rack. QCT QoolRack features its own built-in smart management enables self-adjustment functions such as CDU pump speed, and fan zoning based on the workload of each server in the rack. QCT QoolRack starts at the cooling distribution unit CDU at the bottom of the rack that pumps coolant liquid up through the cold manifold which travels around the CPU to cool down each node. The heat from the CPU is then drawn to the liquid which then passes through a tube piping to the hot manifold. The hot liquid then travels to the top of the rear door radiators for heat dissipation. During the process, fans would draw heat out of the rack. Finally, the heat-exchanged, cooled-down coolant will then enter back into the CDU to run a new cooling flow cycle. In this liquid-to-air cooling solution design, at the top of the rack is the management switch which is serial connected to every server in this 42U solution. 13 QuantaGrid D54Q2U servers can fit beneath the switch followed by a 1U redundant power sled, and at the bottom sits the 4U CDU with its built-in DCSCM for smart rack management that connects to the switch to collect data from each server. For the CDU's management, rack communication is installed under an open BMC architecture. Additionally, a smart link encodes each individual server after booting, in order for the CDU to auto-detect the server's BMC data, monitor overheating, and leakage errors. Based on this smart link, the CDU would use this data to automatically analyze workloads and thermal data or status of the servers to then adjust CDU pump speed, fan speeds, and fan zones. A Redfish API web user interface is also used to monitor thermal conditions, leakage, and fan zoning for every node. For the fan zones, the CDU manages each node's workload to zone 16 fans into 2 to 4 fan groups to balance the coolant's temperature and decrease power consumption. And for serviceability, each individual fan can be taken out, and 4 fans are grouped into one fan board where each fan board can also be opened. The CDU and its coolant filter are also hot swappable, and the CDU pumps are all redundant. The fan zoning feature of the QCT QoolRack effectively reduces fan duty, which improves the power usage effectiveness or PUE. Aligned with QCT's deployment flexibility and liquid-to-air heat dissipation, rack utilization goes up as data center operational expenditures go down, which in turn helps our planet and environment. QCT QoolRack, your best choice towards an optimized green and sustainable data center.